Quantum properties of nuclear states. Nuclear energy levels A. Similar to the discrete energy states of the electrons in an atom, the nucleons comprising a nucleus have possible energy states given by Heisenberg principle (MeV). First variety 1.462 plus 1.343 plus 1.100 plus 0.802 plus 0 plus Hn psi n is equals to En psi n. Here, Schrödinger wave function psi n depends upon spatial coordinates and also spin and isospin quantum number. The ground state possesses latent energy in the form of potential energy which is normalized to zero. Excitation energies of higher levels are referred to the zero energy of the ground state level. Gamma rays of discrete values are emitted by de-excitation of the nucleus to its ground state. The energy level diagram represents excitation energy, nuclear spin L, parity pi, lifetime T, isospin T. B. Nuclear angular momentum. Pauli, while explaining hyperfine structure of spectral lines, he suggested that certain atomic nuclei may possess an intrinsic angular momentum as well as magnetic momentum. Since nuclei are built up of neutrons and protons, each possesses an angular momentum which the center of the nucleus an intrinsic spin angular momentum of half h cut for nucleon corresponding to total angular momentum quantum number I. The absolute magnitude of total angular momentum is h cut of I into I plus 1 power 1 by 2. The value of I depends on the type of interactions between nucleons. LS coupling. In this case of spin orbit interaction is ineligible and there is a collective interaction of orbital and intrinsic momenta, that is I is equals to L plus S, L is equals to sigma I Li and S is equals to sigma I Si. For L is equals to 0, 1, 2, 3, so on, we have levels S, P, D, F. For each value of L, there are 2s plus 1 possible separated energy levels. For L is equal to 1, S is equal to 1 by 2, we have levels 2p 1 by 2 and 2p 1 by 2, the spin doublet. JJ coupling. In this case of orbital and spin momenta of each individual nucleon are strongly coupled. I is the vector sum of individual j values. I is equals to sigma ij, where ji is equals to Li plus Si. This type of coupling is called strong spin orbit coupling. If n is equal to 0, j is equal to 1 by 2, n is equal to 1, j is equal to 3 by 2, 1 by 2, then I is equal to 0, 1 or 2. The total angular momentum of a nucleus is usually called as nuclear spin. C. Parity. Nuclear parity is the product of the particles of nuclear constituents. System of n particle is given by sigma L n. Parity is even if the sum is positive and is odd if the sum is negative. D. Isospin. For a given nucleus, the value of Tz is just the minus 1 of the neutron excess. Tz is equals to 1 by 2 z minus 1 equal to minus 1 by 2 into z n minus z. The statistics. It can be seen approximately that H1 Li7 F19 Na23 P31 Cl35 obey the Fermi-Dirac statistics. In general, all nuclei of odd mass numbers obey Fermi-Dirac statistics. He2, He4, C12 and 14, O16, S32 are no to obey Bose-Einstein statistics in general. Photons are all nuclei of even mass number follow Bose-Einstein statistics.